Okay, continuing with law of signs, we're going to look at what we call the ambiguous case. So the ambiguous case is where we have two side lengths, we're given two side lengths, and then an angle that's not between the two sides. So I drew you a little picture here. So say we're given side A and side B, and then angle A. Notice angle A is not between side A and side B, so this is side-side angle. And now the issue with given this sort of information is what's happening with this third side. Now, depending on how long that third side is and how big this angle is over here, we have a couple of different things that could go on. The first thing is that we could have a nice ambiguous case where this leg is just the perfect length where it comes down and it forms one triangle and it behaves and we're done. So we could possibly get one triangle out of this. It could also be the case where this is it. This third side right here, it just falls short and doesn't actually connect to the other side. In that case, we would be done, and so we would have no triangles. But it could also be the case where the side lengths and the angles just line up perfectly, where it either swings out and makes a triangle, or it swings in a weird little fashion and makes a second triangle. So we could possibly have two different triangles with the same bit of information. And again, depending on the information that we're given, will determine how many triangles we actually have. So this one is a little bit more involved. But again, if you look at the back of your homework, it does nicely break down step by step when this happens, when we do have a side-side angle, what to do. So let's go ahead and look at an example and run through this. Do note that as you're going through this, the letters will change depending on your given information. So this, like the ambiguous case, is if you were given angle A and side B. But note these values, the letters will change depending on the values that you get. So make sure that you do line that up. So let's go ahead and do an example of the ambiguous case. So let's say that we are given angle A is equal to 89 degrees, side A is equal to 15.6 degrees, and side B is equal to 18.4 degrees, not degrees. Angle A is 89 degrees, side A is 15.6, and side B is 18.4. It's already given away that this will be the ambiguous case, side-side angle, but again, as we start adding to this, it will be nice to be able to identify what case we have and what we're going to do with it. So I'm going to go ahead and label my triangle. I'm going to let this be angle A, which means this is side A, and I'm given both of those. And side B, I can let this be angle B, so this would be side B. Regardless of which one you chose, I do have side-side angle. Notice again, this is not the angle that's in between them, so it is side-side angle. So I do have the ambiguous case. So I do need to go through my checklist. So I have two different cases for the ambiguous case. And it goes off of the angle that we're given. So case 1 says that the angle we're given is between 90 and 180 degrees. So the angle that we're given is 89. So this is not case 1, this is case 2, where the angle I'm given is between 0 and 90 degrees. So I have different bullets that I need to check to see actually how many triangles I have. So the first one is the side that corresponds to the angle I'm given, in this case it is A, is that side bigger than the other side? So I'm given angle A, and I need to check, is the side that corresponds to that angle larger than the other side? And this is not true. 15.6 is not larger than 18.4. So I don't have this case right here. It would be nice if I did, but I don't. So I need to go on. So it says otherwise, if this is not true, find this value, find H. And H is B times sine of A. So I need to find H, which is equal to B times sine of A. And again, be careful with this. If you're given side C, or angle C instead, then angle C should be in here, and the side other than side C, whatever you're given, should be here. So just be careful to line up that information. So in this case, I have H equals 18.4 times sine of 89 degrees. Again, handy dandy calculator wherever I put it. I have 18.4 times sine of 89, which gives me approximately 18.4. Okay, so we need to go through our checklist again and figure out what is going on. So we found our H value. So the first thing to compare once we find H is that the given side that corresponds to the angle is less than H. So let's see. Is A less than H? And in this case, A is less than H. Right? A is less than H, and it tells me that if this is the case, then I have no triangle. So 15.6 is less than 18.4, meaning my A is less than H, so I have no triangle. And I'm done. Right? So going through, checking, it's possible that I have no triangle. All right, sadly, that will not always happen. So let's do another. So let's say this time that I'm given angle B is equal to 36.5 degrees. And side C is equal to 24. And side B sorry, let's make this side B. B is 24, and side C is equal to 34. There we go. So angle B is 36.5, side B is 24, and side C is 34. So I want to go through and solve this triangle if possible. So again, I'm going to draw my picture and label, let's say this is angle B, and across from that will be side B, which is what I'm given, and side C will be one of the other two. Honestly, does not matter which, as long as my angles and my sides that correspond are across from each other. So I do have side-side angle. So this is the ambiguous case, so I do need to go through my different cases and my different checkpoints. So going back, this is side-side angle, so I do have the ambiguous case. So again, I need to check which case do I actually have. Remember, the first case is if the given angle, in this case is angle B, if it's obtuse, if it's between 90 and 180. The angle we're given is 36.5, so we don't have case 1, we have case 2. So I need to check, is the side that corresponds to the angle we're given, so in this case, the side that corresponds to the angle is B, so we're looking for this first one right here, is B greater than or equal to C? And that's obviously not true. B is not greater than or equal to C. So again, I do need to find this H value. So H is going to be sine of the angle I'm given times the other side, right? Not the side that goes with the angle. So I'm going to have, in this case, C times sine of B, which is 34 times sine of 36.5. Handy dandy calculator, 34 sine 36.5. And this gives me approximately 20.22. And so now we'll use this value to compare the other sides. So once we find H, we're wanting to compare is the side that corresponds to the given angle, so in our case, we're looking at side B, is it less than H? So side B less than H, B is 24, H is 20, so no, that is not true. So sadly, we don't have the case where there's no triangle, so we'll keep going. Is the side that corresponds to the angle, so again, in this case, B, is it equal to H? No, 24 is not equal to 20, so I don't have the case where I have a regular right triangle. So we'll keep going. Is H less than the side that corresponds to our given angle, so in this case, B, and is that side less than the third side? So is H less than B, and is B less than C? And H less than B less than C. So that means is 20.22 less than 24 less than 34. And those are in the correct order. So we do have the case where we have two triangles, which is not too big of a deal, just a little more involved. We have to solve using the law of sines twice. And so the first time we run through it, we're going to do it just like normal, just like we did on the previous video. And then we'll do it a second time. So let's go ahead. And so it says triangle 1. We're going to find B1 is acute, so solve using law of sines. So what that means is the information I'm given, I have angle B and side B, and I have side C. So the only thing I can do right now with the given information is find angle C, right? The other angle that corresponds to the other side. So we're going off of this angle C. So we're going to solve it just like normal, just like we did on the previous video. So starting by finding angle C using the law of sines. Angel C. All right, so we're going to be using sine B over B equals sine of C over C. Right? That is just the information that we're given. It's everything we have. So I'll have sine of 36.5 divided by 24 equals sine of C over 34. And we'll solve it in the same way that we did last time, cross multiply and divide. But notice here that I'm trying to find an angle. And if you recall, what do we do when we're trying to find an angle? We need to use the inverse trig function. So cross multiplying and dividing, I'm going to end up that sine of C is equal to 34 sine of 36.5 divided by 24. Now I'll figure out what that is. So 34 sine of 36.5 divided by 24 gives me sine of C is approximately 0.8427-ish. I don't like rounding very much. But so to find what actually angle C is, I need to use the inverse trig function, right? So angle C is going to be sine inverse of that value that we just got. So putting that in the calculator, sine inverse of that value, I'm going to get approximately 57.4. So we found angle C is 57.4. So now I have angle C, I have angle B. I can figure out what angle A is just by subtracting B and C from 180, and then we can find side A. So angle A is going to be 180 minus the given angle, which is 36.5, minus 57.4. So we have 180 minus 36.5 minus 57.4. And we get angle A is approximately 86.1 degrees. So now that we know what angle A is, we can use the ratio for the law of sines with A to find what side A is. I like to be consistent, so I'm going to keep with sine of B over B, just like we did for angle C. But this time we'll be finding side A. So I have sine of B divided by B equals sine of A divided by A. So filling in all the information that I know, sine of 36.5 divided by 24 is equal to sine of, we just found A to be 86.1, divided by side A, which is what we want to know. So again, cross multiply, divide, I end up that A is equal to 24 sine of 86.1 divided by sine of 36.5. So I get A is approximately, handy dandy calculator, again be sure you are in degrees, divided by sine of 36.5. I get 40.25. And so now we solved the first triangle. All of our given information is still the same. I know that angle B is equal to 36.5 degrees. I know that side B is equal to 24, and side C is equal to 34. Everything else I'm going to give a little subscript of 1, because this is just the information for the first triangle. So when we first found angle C, the very first thing we did, so C sub 1, so this is for the first triangle, we found that to be 57.4 degrees. And then likewise with angle A sub 1, we found that to be approximately 86.1 degrees. And then when we found side A, again this is just side A for the first triangle, it's 40.25. Alright, so remember, I know that was a long process, but this is the ambiguous case, the case where we have actually two triangles. So we found the first triangle. Now to find the second triangle, we're going to go back to the very first thing we did when we found out that this was the ambiguous case with two triangles. So the very first value we found was this angle C. So to find all the values for the second triangle, we're going to take what we found for that first angle, so 57.4, and we're going to subtract it from 180. That's going to give us a new angle, our angle C2, if you will. So we're going to take, so this is for our second triangle. This is triangle 2 information. And this happens every single time that we have two triangles. We're going to take the first angle that we found from our first triangle, and we'll subtract it from 180. So C2 equals 180 minus 57.4. So C2 equals 180 minus 57.4. We have 122.6. Now the whole rest of the process is going to be exactly the same as the process that we did for the first triangle. We'll just be using this new value for C. So angle C is 122.6, and we're going to keep all of our original values. So I still know that angle B is 36.5, that side B is 24, and side C is 34. So I know angle B and angle C. I know side B and side C. Now I just need to know all the information for A. So since I have angle B and angle C, then angle A2 is going to be 180 minus 36.5 minus 122.6. So I have 180 minus 36.5 minus 122.6. So I get 20.9 degrees. And now that I have angle A, I can use that to find side A. So let's go ahead and find side A. So my ratio, again, I like to be consistent, so I'm going to stay with B. So sine of B over B equals sine of, in this case, A sub 2 over A sub 2. So plugging in all of my values, I get sine of 36.5 divided by 24 equals sine of our new angle A, which is 20.9, divided by A sub 2, which is what we need to find. So again, cross multiply, divide, I get A sub 2 is equal to 24 sine of 20.9 divided by sine of 36.5, which putting in my calculator, divided by sine of 36.5, I get 14.4. So we have finally solved all of our triangles. So these are all the values for triangle 1. And for triangle 2, we have all of our same given values. So angle B, and side C will remain the same. So angle B is 36.5, side B is 24, side C is 34. And remember, we had a different angle C, so C sub 2 we found to be 122.6 degrees, and angle A2 we found to be 20.9 degrees, and side A sub 2 we found to be approximately 14.4. And again, going through and checking that our answers actually make sense, our largest angle should correspond to the largest side length. So for triangle 1, largest angle, largest side, smallest angle, smallest side, and for triangle 2, largest angle, largest side, smallest angle, smallest side. So they do line up, and I have all of my values for triangle 1 and triangle 2. So I know it seems like a long, tedious task, but it does get better with practice. So work through the homework. If you have any questions, please don't hesitate to text me. Other than that, I will see y'all on Monday. I hope you have a great and safe weekend.